300 kilometers off the coast of Newfoundland, 280 men and women endure unforgiving weather and isolation. They call this island Hibernia.
It's really an awesome sight when you see it, and you know, I've been out, I don't know, over 100 times now, and it's always nice to see it every time you go out there.
At almost half the height of the Empire State Building, and nearly 3 times as heavy, the Hibernia offshore oil installation is like an urban skyscraper that has somehow gone lost, burning a torch in hope that her city will find her.
What you're dealing with really is a small island. It's roughly 1.2 million tons, which is quite a large facility, even in comparison with North Sea offshore platforms.
Offshore oil rigs inspire a certain fascination, perhaps because they seem to be the most defiant of human structures.
This is, without doubt, one of the world's mega projects over perhaps the last 10 years.
From its beginning, Hibernia has challenged the limits of science and technology, a direct descendant of the Egyptian pyramids and the Great Wall of China.
This is the largest construction project in North America right now, and it's probably in the top 5 in the world.
But despite its size, Hibernia is still dwarfed by a powerful range of natural forces, from the crushing strength of icebergs.
9/10 of it is underwater, and with the current pushing it, you know, you're talking probably 1 million tons. Actually, it's the same weight probably as what this platform is.
To the blinding power of a shapeless enemy that cannot be touched.
But this is the only place in the world where you can get fog at 200-kilometer wind. It's fog that stays, it does not go away. It just keeps regenerating itself.
The engineers of Hibernia have tried to learn from the tragic lessons taught by the disasters of previous oil rigs.
The area over here has had its tragedy with the Ranger, which is always in the minds of people on board here.
You can't run away from it very far if there is a fire on board.
And we believe at this point that we can get the 280 people off the platform using the jummy-vac in about 90 minutes.
Strip away the science and technology, and inside you'll find a unique community of 280 people surrounded by the North Atlantic Ocean.
It was a big shock when I first got here, I'll tell you. I didn't understand a thing on the menu.
On the menu tonight, we got codfish on, braised cod.
We have 140 rooms altogether, and there's 2 people per room.
We got the meat sauce here tonight for the spaghetti. As you can see, it's a little bit bigger than your one at home.
Long way, 315 kilometers from St. John's and a few thousand kilometers from Ireland.
I enjoyed the 21 days out because we know we got 21 days ashore.
Hibernia's modern history begins in August 1979, when Mobil Oil drilled an exploratory well in the North Atlantic Ocean. At the other end was the 7th largest oil field in the world.
To find, on a worldwide basis, a 200 million barrel oil field is a very large oil field. 500 million barrels, say like a Hibernia, that's classified, of course, as a giant.
But there was also a giant problem. The oil lay defiantly beneath one of the most hostile environments on Earth.
When you're out here on one of these and you're having 75-foot seas, I mean, it's one of those things you can't imagine. You got to be there.
Lots of high winds, low visibility, lots and lots of fog, cold temperatures, icing conditions, just about everything you can throw at a helicopter.
6 months of the year, you are dealing with an ice season.
We were fogged in the other week for a whole week. Couldn't fly. We've got sophisticated helicopters, radar, and we couldn't get a person off the installation. We have no control over that fog whatsoever.
Close your eyes, walk into a white wall, and open your eyes when you touch it. And what you see is fog on the Grand Banks. Pure white.
What was needed was no less than the strongest offshore oil platform ever built. It would be 12 years before a group of oil companies were ready to begin construction in 1991. The first step was finding a location that could contain the monster oil rig. The answer was found an hour-and-a-half drive from St. John's, Newfoundland. Bull Arm is a small sheltered inlet. with water deep enough to accommodate the finished platform. Preparing the building site was a major construction project of its own. It would take 400 workers 2 years and $300 million to prepare the 4,000-acre site. Then construction began on Hibernia's most unique feature, the gravity-based structure, known simply as the GBS. It is 85 meters tall and weighs 550,000 tons, the equivalent of 5 aircraft carriers. All but the very top of it remains submerged below the surface.
When it's actually sitting in its final resting spot on the Grand Banks, the floor that you're on right now will actually be 85 meters below water.
Most of the weight is from high-strength concrete, an elite cousin of the cement found in sidewalks.
The requirement for strength for the concrete in the GBS is 69 MPa. It means about twice as much as what we would normally use, say, for a floor slab or sidewalks in normal construction. So it's probably about twice the strength.
The other main ingredient is reinforcing steel bars known as rebar. They provide strength and flexibility to an otherwise brittle concrete mass.
The reinforcing steel provides the resistance to any impact or thing, gives it strength. Concrete itself doesn't have strength. The reinforcing here is probably some of the heaviest reinforcing. It's heavier reinforcing than in a nuclear power plant.
Where the Eiffel Tower has 6,000 tons of steel, the GBS contains 100,000 tons of reinforcing steel. At 85 meters in height, the GBS required a special process to form its concrete walls. Known as slip forming, wet concrete is poured into the top of a metal form. As this mold moves up the wall at a rate of 1 meter per day, the concrete has time to dry, becoming solid by the time the form has moved past it. Once completed, the GBS will become a huge floating concrete platform, 85 meters deep. Inside, 4 main shafts house a complex array of piping and equipment.
The building utility shaft has a computer model. It's in that utility shaft you'd find, for instance, the crude oil pumps, and you'd find ballast water pumps, an enormous amount of piping and equipment. And all this equipment and piping has to be placed all within a very constricted space.
Over 300 engineers contributed to the design of the gravity-based structure, working on every detail, from the outer wall to choosing which reinforcing steel rod to squeeze into which nook of the GBS.
We've got a we've got a high QA program here. It's what they call Z299.1, and it's about the same level of detail you need to design a shuttle, a space shuttle.
Building the GBS required a total of 13 million hours of labor. One person working a 40-hour week would have finished the GBS in the year 8,495. Mating the GBS with its new partner, resulting in the world's largest offspring. While the gravity-based structure was being built in Newfoundland, construction companies around the world were working on its future mate, the operating platform which now sits on top of the GBS. The operating platform is made up of 5 separate modules. Each module has a different purpose, from housing the workers to operating the air and water systems to the actual drilling derricks. 2 of the modules were built in Italy, 2 in South Korea, and 1, the drilling platform, at Bull Arm in Newfoundland. The 4 modules from Italy and South Korea were towed halfway around the world to Bull Arm. All 5 modules were then joined together as a single platform. The next step was the mating of the topsides with the GBS. The floating GBS was first lowered by letting water inside. The topside platform was then towed out and positioned over the gravity-based structure. Once in position, the ballast was removed from the GBS, raising it back up to join with the operating platform. The new offspring entered the world weighing in at a healthy 1.2 million tons, with a total height of 224 meters. In the spring of 1997, the newborn Goliath took its first tentative steps, a 10-day journey into the heart of the North Atlantic. 9 tugboats provided the propulsion. Their average speed was less than 5 kilometers per hour. Once the platform was over the Hibernia oil field, precision instrumentation helped them plant their new island within 2 meters of where they wanted it. The gravity base was then grafted to the ocean floor by replacing the mud at its feet with 100,000 tons of concrete. Finally, 550,000 tons of iron ore was pumped inside the GBS to provide additional ballast. The Hibernia oil rig was now firmly planted on the ocean floor. It had taken almost 20 years to design, build, and install the Hibernia platform. The cumulative effort of thousands of workers, from scientists and engineers to welders and pipe fitters. And it came with a hefty price tag.
I'm sure it took a lot more money to send someone to the moon, but for an oil company, 5.8 billion is a pretty significant piece of expenditure.
The oil rig was built for roughly a third of the cost of conquering the moon. But Hibernia might ultimately yield a staggering $11 billion in crude oil, providing the platform can stand up against some of the most powerful forces on Earth.
We'll have hurricane-force winds. The seas themselves can be quite extreme, very high waves. So all of that contributes to the aspects of a harsh environment.
If anything, on the Grand Banks, we have the utmost respect for it and the conditions that come along with it, of course.
Part of that respect comes in the form of the world's most advanced weather forecasting technology.
It'll give you some wind,
Clouds,
waves,
precipitation,
swells,
barometer,
temperature,
and dew point, and visibility. There's sensors mounted all over the platform. Most of them are right here just off the helideck. We got anemometers there to give us the wind speed, and we have our temperature sensors. We have our sensors there for giving the cloud height and stuff like that.
This information is critical when it comes to supporting both marine and aviation operations offshore.
However, even the most sophisticated technology stands impotent against one of nature's most paradoxical elements.
What the hell is fog? Everybody says, everybody curses it, particularly us folks here in Newfoundland. I mean, this is why when the sun shines, everybody takes a holiday.
Scientists on the East Coast are now trying to penetrate the mysteries that enshroud our understanding of fog.
Fog is really, well, very simply, it's small droplets of water. It's vapor. We don't know whether it's nucleating around bits of salt that, comes off the spray, ocean spray breaking and then drifting up.
This weightless white adversary can take an enormous toll on Hibernia's financial health.
A missed flight could cost Hibernia typically $4 million a day if there's a critical part that cannot get onto the rig. On the human side, there are people who are there for 3 weeks. They're desperate to get off. And likewise, there are people at this end who have to get on there. And that creates other morale problems.
And if you get fogged in, you're probably going to be here for a few more days. That's quite a challenge to deal with your emotions, and you're psyched up to go home, and you might not get to go home, and family and plans and everything are waiting, and they got to be put on hold. And I think that's quite a challenge right there in itself.
So it's really very important for helicopters to be able to get in and out in almost zero visibility conditions.
The Center for Cold Ocean Resource Engineering, or CCOR, is now trying to learn if fog can be predicted.
What we're trying to do is to actually characterize fog. Nobody has done it. People have fog chambers in laboratories, and they say they know the characteristics of it, but in terms of forecasting fog here in St. John's or on the Grand Banks, it's still a black art.
Hibernia's most powerful natural enemy, when we return to Forbidden Places. Anchored to the ocean floor and exposed above the surface, Hibernia is prey for some of nature's most powerful predators. Set free from the ice sheets and glaciers of the Arctic, icebergs migrate south, their frozen beauty hiding a deadly menace. And the Hibernia platform is planted right in the middle of their migration path.
Some people term this area of the Grand Banks as Iceberg Alley. We have a lot of bergs that come down off the coast of Labrador and they'll proceed out around Newfoundland, and they'll work their way out and come down to our area here.
The most famous victim of Iceberg Alley lies on the ocean floor 250 kilometers south of Hibernia. At the time, the Titanic was also considered unsinkable. Because the Hibernia platform cannot move out of the path of a threatening iceberg, engineers have developed a multi-layered defense. But iceberg behavior is not an exact science.
The interesting thing about icebergs, though, it has no one defined route. It can change with the environmental conditions at the time. So wind, and especially the current dictate how that iceberg is going to move.
These floating mountains can be heavier than the Hibernia platform itself.
It's like trying to stop an elephant. 2 million tons moving at any speed has a lot of energy stored within it.
Hibernia must protect not only its platform, but also the 2 kilometers of pipeline laid down on the floor of the Grand Banks. When icebergs from the deep Arctic seas arrive in the relatively shallow waters of the Grand Banks, they run out of room to float. As a result, the iceberg will scour the seabed, creating an ominous scenario for Hibernia's pipeline.
When they scour, they dig into the ground, so you can imagine the damage they can do if they scoured next to your pipeline. They can literally take your pipeline right out.
Against icebergs, the Hibernia engineers have adopted the attitude that the best defense is a good offense.
We have a target in the northeast quadrant located, a large iceberg, it looks like, Captain.
The multi-layered iceberg defense system begins as far away as 40 kilometers. Hibernia's first line of defense employs radar on a 24-hour watch for the approach of icebergs.
These are what's referred to as ice management zones. The red circle, that's a 6 nautical mile radius from the center of the platform. The green, that's a 24 nautical mile radius, and beyond 24 nautical miles is another zone.
We know when it's getting in our area, and we know at what time we have to take some action to handle it.
You'll probably have seven different classified types of bergs, whether it be blockies, tabulars, domes, bergy bits, things of that nature.
Once a potential threat is spotted, Hibernia proceeds to the second phase of its defense system. 3 specially designed ships. Far away from the platform, these vessels work as armed sentries against invading icebergs, directing them away from a collision course with the platform.
All we would have to do is move it very small amount so it would deflect and miss the platform.
If you deflect 60 miles away a small degree, or a couple of degrees, by the time it gets 60 miles towards you, obviously the distance away it's much more significant.
The ships have 3 methods of deflecting icebergs off their course. The first one involves using their own propellers.
One is called propeller wash. It's when you actually back your vessel in towards it and then steam away. You create a wash with the current and it pushes it away.
The second method is reminiscent of the rodeo cowboy. Hibernia's vessels are equipped to lasso an iceberg and drag it off its course.
Right behind me, you will see a spool of iceberg tow rope. It's 3 400-meter sections. It's a poly-braided propylene rope that floats, which is very important in the way that we actually tow an iceberg. And it's 4.5-inch diameter, so you can imagine that it's quite big.
The third and final method of iceberg deflection relies on water power.
All Hibernia vessels have water cannons on their bridge, and with sufficient flow and pressure from them, you can shoot the piece of ice away from you. It could take from anywhere from hours to days to move an iceberg off its track. And that's depending on the size and is totally dependent upon the environmental conditions at the time.
The last line of defense is the platform itself. The outer wall of the gravity-based structure is the only one of its kind in the world. The 16 concrete teeth around its circumference are designed for direct contact with an iceberg, while the inner walls absorb the impact and redistribute it throughout the GBS. So how big an iceberg could the Hibernia platform withstand? engineers have arrived at their answer employing tactics often used by the professional gambler, the science of probability.
Hibernia has designed for a 10,000-year iceberg, which is a 6 million ton iceberg. And a 6 million ton iceberg, if it ever came in contact with the platform, would do damage, but it would be repairable damage.
But icebergs are unpredictable natural forces, and nature has an uncanny ability to defy the odds.
If you get 10 bergs coming down here tonight, it may be that you're going to get in a situation you're not going to be able to handle all of them.
Uncovering Hibernia's origins over 100 million years ago, when we return to Forbidden Places.
It's true all over the world for most of these reservoirs. The recovery rates are anywhere from 20 to 35%, and the remainder, they just sort of close up the well and leave it there. There's no way to get it out.
According to current projections, over a 20-year period, the Hibernia oil reservoirs will relinquish about 600 million barrels of oil.
There's still 2.4 billion barrels sitting down there that they can't get. They don't have access to. Why? Because it's trapped within the rock down there. And they have no way right now of getting that out of the rock.
Another major challenge to the engineers is size. On a human scale, the Hibernia oil rig is huge, measuring over 100 meters across. But on a geological scale, the rig is dwarfed by the oil reservoirs, which measure up to 8 kilometers in length.
The reservoir has got a large aerial extent in this area, and the platform's obviously a small point in the middle of that. So what we have to do is drill wells out to various parts of the reservoir so we drain the oil from each portion.
Which means the Hibernia oil engineers cannot simply drill straight down from directly under the platform.
One of the biggest advances is the steering arrangement that we can have with our bit.
Just above the drill bit, a computer processor sends sound pulses up the drill string. The sound pulses act like a Morse code, providing location data.
We know from the surface exactly where the bit is, and we can make appropriate adjustments.
The angle is set in the drill motor before the pipe goes down. But during the drilling process, the angle can be adjusted by applying more or less pressure to the drill bit.
Well, the types of angle we use, the build rate is maybe 2 or 3 degrees per 30 meters.
Over thousands of meters, these small increments can produce dramatic changes in the well's direction.
The pipe, although looking very, very rigid, has actually got enough flexibility, more than enough.
The location data sent up by the computer allows the drill team a degree of accuracy that rivals a military sharpshooter.
This well that we're drilling now, I believe, is around 6,000 plus meters, and you can be within, a few meters either way of inaccuracy from right underneath the drill floor to where you end up landing the well. So the accuracy in it is pretty good.
When a drill finally does tap into an oil pocket, the stereotypical gusher is not a welcome sight to the modern oil engineer.
That's an uncontrolled flow. The pressure drops off, and you can't get much more oil out very quickly, so you get a very low recovery.
But even under a controlled flow, the pressures of the Hibernia field constantly change as the rig interacts with the reservoir.
If you put a hole in the balloon and start to let the air out slowly, things change. The balloon gets smaller. What we do, we take the hydrocarbon out of the ground, and the dynamics change. The pressures change, the rates of oil change.
Oil came out of Hibernia's first well at the surging rate of 40,000 barrels per day, but dropped off to 15,000 barrels in the course of a few weeks.
So what can they do? They have to repressurize the reservoir somehow.
The answer lies in putting fluids back into the space they've been draining.
What they do is they drill another well called a water injection well, and once that's finished, they start to pump water down into the oil reservoir. That will drive the pressure up and drive oil and water as well up through the producing well so they can get more oil out.
The oil industry is highly motivated to develop more efficient ways of extracting oil from the prehistoric sandstone.
And what we're trying to do is find methods for them to get another 1 or 2 or 3% of that out of the ground. And to them, that means millions of dollars.
Once recovered, the oil is fed into the GBS, or gravity-based structure, which serves as a huge underwater storage tank.
The GBS itself is divided into 3 sections that we call storage cells, and we have the capability to store about 1.2 million barrels of crude, which is quite a bit.
Once the GBS is full, the oil is offloaded into a tanker anchored 2 kilometers away from the platform to minimize the risk of collision. The oil is pumped from the storage cells in the GBS through an underwater pipeline. From the initial extraction to the final loading, the oil is never exposed to the outside environment.
Normally we load a tanker 850,000 barrels in 16, 18 hours.
A tanker of crude oil is almost enough to meet the daily energy requirements of Canada. In their projected lifespan, the Hibernia reservoirs will fill over 700 tankers.
Luckily at the moment it looks like we're finding it at a faster rate than we're producing it, but logic would say that that's got to stop sometime.
Though the process of finding, drilling, and delivering oil is highly technical, for the scientists and engineers, it's a process carried out with passion.
Well, for myself, I feel extremely fortunate in that people are paying me to do something I'd be down here trying to do every day anyway, whether they were or not.
I think I've been doing this for 20 years, and by the time you drill a well, in a way they become almost a personal friend.
Protecting the people of Hibernia in the face of disaster. When we return to Forbidden Places. On nature's grand scale, it is little more than a steel postage stamp surrounded by the Atlantic Ocean. For the 280 employees on board, the Hibernia platform is a 100 square meter village separated from the rest of the world by 315 kilometers of ocean.
When you look at the platform, you know, it's only a little over, 300 foot by 300 foot. So if things go bad, you don't have a lot of options.
Offshore oil rigs have been the settings for some of the most disturbing industrial accidents of the last quarter century. The Hibernia engineers have tried to learn from the dark history of the North Atlantic.
You got to realize that you are in a harsh environment. It's pretty unforgiving. Normally in this type of industry, if things go bad, they go really bad.
Just how bad was tragically demonstrated in February of 1982. A floating rig, the Ocean Ranger, was in its 15th month of exploratory drilling on the Grand Banks when it was attacked by a storm with winds of 130 kilometers per hour. At the time, it was considered one of the safest platforms in the world. But a computer malfunctioned, and the force of 65-foot waves combined to capsize the rig. All 88 men on board died. Only 22 bodies were found. For the crew of the Hibernia, it is a tragedy not easily forgotten. Many lost friends and relatives who were on board the Ocean Ranger.
We had a memorial service here on February the 14th to commemorate the Ocean Ranger. And from this very spot right here, we put a wreath into the sea to commemorate that.
Heeding the hard lesson of the Ocean Ranger, Hibernia has made an enormous investment in safety technology. The designers and engineers have developed 3 different means of emergency evacuation.
And this is one of them. This is what's referred to as a Gemini-vac system, and this is the Gemini-vac terminal on the ship side.
It's a dry evacuation. We leave a safe refuge and we go to a safe refuge.
So nobody has to get in the water. It's just like you're on a ski lift. The gondola itself carries 16 people at one time.
We believe at this point that we can get the 280 people off the platform using a Gemini-vac in about 90 minutes. And once you're aboard the vessel, of course, you're safe.
The Gemini-vac system is designed to work in 8-meter seas and 70-kilometer winds. The vessel uses GPS, or Global Positioning System, to maintain its position in rough seas.
The evacuation system associated with the gondola or the GEMEVAC evacuation system. That's the only one in operation in the world.
The second method of emergency evacuation revolves around specially designed lifeboats.
We have 8 lifeboats. We have 6 here on the south end of the platform, 2 on the north.
The enclosed lifeboats are motorized and have self-righting capability.
And the other means of escape would be by the sea directly through the Sealantic skyscape system, which you see right here off to the right.
There are 3 chutes on the platform, capable of handling all the personnel.
And that's a net which will take you from here down to the sea and into a life raft. That would be the least desirous means of getting off the platform.
Before being accepted on board, all the men and women of Hibernia must embark on a rigorous, sometimes terrifying survival training course.
We practice, for everything from gas leaks to helicopter crashes to fires, man overboard drills, all those sort of things that could happen.
Helicopters are the primary umbilical cord to the mainland. Weather permitting, there are 2 daily flights to the platform. The 315 kilometers takes about an hour and a half, 12 passengers at a time. They are protected from the vast expanse of dangerously uniform ocean by a sophisticated tracking network. A global positioning system unit in the tail of the helicopter allow mainland personnel to monitor the helicopter's flight.
This system reads the position of the helicopter every 5 minutes automatically through the network and back into our operations center. And therefore, our radio operators can see the helicopter moving across the fleet locating and graphics monitor screen. Should a helicopter not transmit a position, the graphics workstation goes into an alarm state. In the end of the day, you have the safest helicopter transportation system that is possible to operate.
But if a helicopter is ever forced into the ocean, Hibernia personnel will be prepared. They must undergo a forced landing simulation. In the water, a helicopter will quickly turn upside down. Employees learn to orientate themselves and escape through the windows. They must also wear cold water survival suits, designed to protect them from the life-draining cold of the North Atlantic Ocean.
After the incident in the North Sea with Piper Alpha, then the focus became on blast and fire.
Planning for the ultimate horror on board an oil rig when we return to Forbidden Places. Our dependence on combustible energy sources is a double-edged sword. The very reasons that we covet oil to run our engines also make it a potentially lethal product to pull from the earth.
And wherever there's hydrocarbons, there's a risk of fire.
Hydrocarbons, it doesn't matter whether it's on land or out in the middle of the ocean. The danger is still there. We can't run away very far or very fast if there's a fire.
This potential danger has already ignited into a horrifying reality. The North Sea, July 6, 1988. The Piper Alpha offshore rig experienced a gas leak. The gas quickly ignited into a series of devastating explosions. The crew, all 167 men, perished.
After the incident in the North Sea with Piper Alpha, then the focus became on blast and fire in sequence. And we were one of the few first platforms after the inquiry came through to start looking into it or investigating into taking into consideration the blast.
Hibernia has gone to extraordinary measures to minimize the risk of a life-threatening outbreak of fire.
From this screen, we monitor all aspects of the fire protection system on the rig. I can tell what end device, being a gas detector, heat detector.
I think the amount of detectors we got is about 2,500 devices throughout this whole platform, with about 500 to 600 gas detectors, specifically just looking for gas on this platform.
And that's very important for determining if a gas cloud is moving across the rig anywhere, for directing fire teams how they can safely have ingress to the area.
If there's any gas released into the atmosphere, it's quickly detected, and there's really no operator intervention required to shut the platform down.
If a fire breaks out, or even a gas leak that could lead to a fire, the platform is engineered to immediately attack it.
We have the mitigation devices, which is the water deluge, which would prevent an ignition theoretically happening.
The threat of fire is low, but training is ongoing. Hibernia has learned from its predecessors to never say never.
But there is a very, very small chance that there could be an ignition. And it's not that, whilst that chance is very, very low, the consequences are obviously really extreme.
Though the Hibernia platform is a sophisticated array of science and technology, it is still run by people. 280 for 3 weeks at a time. It's an unusual village, 100 meters square, surrounded on all 4 sides by the North Atlantic Ocean. For the citizens of this unique community, Hibernia is also a home away from home.
A lot of the morale tends on the food side. You definitely hear if something goes wrong, if people don't like it.
If the food isn't good, morale is gone.
Yeah, well, right now we're feeding up to 275 people. So guys, all set for tonight, which is breakfast, lunch, supper, and midnight meal. There's a high percentage of Newfoundlanders here, so we try to tend to stick with some Newfoundland dishes.
Yeah, it was a big shock when I first got here, I'll tell you. I didn't understand a thing on the menu.
Tonight, we got codfish on.
Dandelion.
Chocolatey clears.
Pork chow mein.
Squid.
Baked Alaska.
What other fancy things?
Newfoundland pea soup.
The most exotic thing I've heard about is seal flipper pie, but I've never tried it yet.
Steak sandwich goes well.
Rices and bread puddings and stuff like that.
We got 3 items on the menu they can choose from. We got the meat sauce here tonight for the spaghetti. As you can see, it's a little bit bigger than your pot at home.
Food being the highlight of the day, you know, to break up the monotony, and people can come to the cafeteria and sit down, and that's, I'd say, where the highlight of the day is.
Hi, I'm Elaine Barrington, and I work in accommodations on the Hibernia platform. I'm just going to show you a little bit of our accommodations. And this is our 7th floor. We have 140 rooms altogether, and there's 2 people per room, and we have 3 shifts working here. So there's always somebody in bed, 24 hours a day. And this is my room. I'll just show you what the room's like. It's not a lot of space, but you don't really spend much time here because you're working 12 hours a day. This is your basic living quarters. You don't have your televisions too loud, and you kind of like respect the other one if you get up earlier. You really live here half the year. You live here equal amounts of here with your family or over here with the other family. It's like our second family.
Alcohol is not allowed on board the platform, nor is smoking allowed for obvious safety reasons. To shield themselves from the ever-threatening sense of isolation, the employees rely on other comforts of the mainland.
We got all the facilities. We got TV, we got the radio.
We can watch TV like the guys on the beach, so we've got 10 channels of TV.
We got the gym, we got pool tables.
We can pick up the phone and talk to our families.
We got everything here.
But that being said, the very fact that you can't go out for a run in the countryside of an evening after work brings home to you that you are on an installation which is isolated.
It's a 3-week rotation, 3 weeks on, 3 weeks off, and it's a very steady pace, day in, day out. It's roughly a 12-hour day. So you're very focused all the time. And at the end of your rotation, you are a little tired, there's no doubt, and the isolation from your family is probably the biggest thing.
Sometimes during your trip, you might get to a point where you really want to just see the kids and go home for a little while, but then, you know, you can't for another few weeks or whatever, so you just adjust.
I enjoy the 21 days out because we know we got 21 days ashore.
And sometimes by the time the 21 days comes around, you feel the stress comes on a little bit. You feel the stress, right? Most of the people are ready to go home after about 3 weeks.
Looking forward to going home.
Until alternative sources are more fully developed, the petroleum industry will continue to quench our thirst for energy. The geologists of Hibernia will devise new technologies to squeeze every possible drop of oil from that vast field. And the people living and working on the man-made island of Hibernia will continue to dance with the dense fog and the drifting icebergs, 300 kilometers off the coast of Newfoundland.
The most challenging? I haven't quite thought of that. I give up smoke and I find that as being a challenge.
That we're the only husband and wife team here.
Well, it's quite a unique experience to work on the Hibernia platform. Most of my working life has been onshore.
Of course, being in Alberta, the nearest ocean is a province away. And it's very hard to describe it to them in detail when most people have never seen the ocean.
I don't think that I've worked on a situation where it's been as high class and as well maintained as the situation we have out here.
So we're talking upwards towards 20 plus years to take this from discovery through to final production.
No matter what we put out here, there is nothing in this earth that is stronger than Mother Nature.
I love it. I think it's absolutely fantastic. It's very interesting work, and it's the beginning of a new era here.